This is the second video of my series where I am going to work on different problems that we face in NLP side. So in first video we basically talk about the how we can clean our data, and in this video what we are going to do, we are basically going to build a model and do cross validation to check how our model is performing. So let's get started. So first I have to make one new file. I name it that like model creation .ipynb. And you can see in the first video we basically clean the data and save that data into the clean.csv file. If I go there, you can see here is our data where we have one category, one text feature, and other is the category. So let's go and build our model. Now we are going to import the packages what we need to build a model. So first I will just import pandas std, then I will import sklearn. Yeah, also I will import xgboost. Let's run that one. Now what I have to do, I have to load a data. Now my data is loaded. We can see the data here, and as we have done some of the pre-processing in the data, this is the pre-processed data, so I am assuming that that we have no null value, right? So let's check that one. Print data dot is any, then I need to check the shape, right? So shape is this and we have no null value. That's good. Now we will try to see the count. So what we can do, as you can see, this is a pretty unbalanced data. So in the first step what I will do, I will just only consider these data and I will remove these three data from the data set, and then I will build a model. In later stage we will check how our model is performing, and then we need to do some kind of like oversampling or undersampling. Let's split the data first. We can just take like columns data, and then we need to do group by category, and then we need to do the filter lambda x, and we can check the length of x, which is greater than, for now I'm taking 100. So what I can do, I will just take the data frame, data dot and is any is in, I think, category, and then what I have to do, I basically have to reset the indexes, and then we do head. So what here I am doing, I am just grouping that data in based on like category, based on this one, the output level, and then I am checking that whoever frequency is more than 100. So here you can see more than 100 is this one. I'm just taking that data, and then I have what I have to do, basically I have to reinitiate the index. For that I am just filtering the data, and then resetting the index, right? So let's do that. Okay, now you can see it has done. So let's check the shape of the data for confirmation. You can see previously we have 37,937 and then now we have 892. So some of the data is gone. So now let's go, and first thing what we are going to do, we have to split the data into x and y. X and y is splitted. Now the next thing is that we are going to feed this data to machine learning algorithms. And if you know the theory of the machine learning, you can know that we cannot operate the machine learning operation or any deep learning operation on the textual data. We have to convert this data into a numerical format. So for that, what I can do, so I will take this data and convert that into a numerical format. For y, what I will do a level encoding. So first I will make a one encoder. So from pre-processing I can level encoder we can import, and then we have to encode that one, that fit transform, basically y, and then we have to do same for the x. And for x what we have to do, so we make one vectorizer, and from feature extraction from text we can import the count vectorizer. So it will basically, what it will do, it will give you a result based on frequency. So if you don't know the theory of all these things, you can comment. I can make a separate video on these topics. So let's call this vectorizer, and first we have to define the corpus. Corpus means like how many words you are going to take account when you are building, you are converting that into a count vector. So like whatever the numbers of words are there in the corpus, the same number of feature you have to predict. So let's first fit that one, fit the data. So when we are fitting the data, what it will do, it will basically build a corpus for us. So I'm just passing the entire x, right? And then I will just take this x and do transformation. Yeah, you can say that why we are doing this fit and transformation separate and separate. You can do fit transform in a one go, but assume that in later phase you have to predict, you will take some of the text and you want to predict that, how you can do. So first you have to pass that through the same vectorizer. So whatever the sentence you have, the dimension of the sentence should be same as the dimension we are using right now when in the x. So we have to pass, so you just have to count the vector transform and you pass that text into that, and it will give you the one vector which have the same dimension that we are right now using here, right? And that will work for you. So let's in the next step what we are going to do, so we are basically going to build first model. So in the first model we are going to build a naive Bayes. It's a basic model, we are not going to do any kind of hyperparameter tuning or anything. Just we need to check that on the different algorithms how this data is performing. So let's name this model something. From the name Bayes I just have to import the multinomial name Bayes. So it's a multi-level classification, so I'm selecting that one. Now from there I have to fit the data, and for fitting the data it's required x uh, sorry, one step I have forgotten. So basically I have to divide the entire data into the x train and a y train. For that I am just using x train x test, then y train, y test, right? And then we have to, like, more from model selection we need to import this one, and we need to pass x y. Random state we can define anything, like 45 I'm just passing. Stratify I can give. Right now we have pretty much very unbalanced data, so we need to use this stratify. So whenever it's dividing into train and test, it will take equal proportion of the labels in each split, right? So I am doing this one. Let's pass this x train, then this y train. After fitting the data, what basically we have to predict. Yeah, we have to do prediction, and for that we need to call mnb, and we have one method in that one called predict. So in the predict we basically have to pass the test data, so it will predict and it will give you all the predictions here. So first thing what I will do, I will here going to use I will here to generate a report. So it's called, from matrices we base matrices, I think it's matrices, yeah, sorry. And from there I'm just have to import the confusion matrix. Let's do one thing, just directly import the classification report, and here we have to pass the prediction, and then we have to pass um, I think it's accepting first the true value then prediction. Okay, so first I have to pass the y test value. So what it will do, so it will first creating an object of name virus, then it's fitting the data into that particular algorithm. After fitting, I'm just testing what are the results of this test data that we have split here, and then we are just building a classification report. And from the classification report we are just passing what is the correct value of this x test and what is the value of prediction, right? Let's run this one, and then if I print this one matrix, you can see we are getting 92% of accuracy. From accuracy perspective you can say that it's a good model without any hyperparameter tuning or doing anything, but it's not. We are basically dealing with unbalanced data, so we cannot rely on this accuracy. We have to see this precision, recall, and f1. You can see in the precision we have 96%, some of them are constant. 84%, it's looking good, but if you see the recall it's very bad, like 26, 0.2%, 12%. And overall if we are talking about the f1 score, we can see 41, 0.4, 22, 92, 82. So it's not good. So f1 score is not good, so we have to work on this one and basically use some of the techniques that we can achieve a greater f1 score, right? So for now just go and use some other algorithms. So one more algorithm I'm going to use is the pretty much common, the xgboost. From xgboost I need to import xgboost classifier, and then what I will do, I have to make an instance of this xgboost classifier, and this one I'm just passing this one. So I am just passing use label encoding as false. If I not pass this one, some warning message is going to give me. You don't have to worry about this field. So it's due to the newer version of the xgboost is giving us the error. And one more error I think it will give us is about the uh, how it's going to evaluate, means like how it's going to check the performance of the algorithm inside xgboost. So we don't have to worry about right now about the warnings, just we need to build the model. So same thing we will do here. We have to pass the train data, then y train we have to pass, and again we can go, we can copy and paste this, the same thing. And if we'll take this one and keep here, let's see, now it's done. Let's see what is the matrix. We need to print this matrix. As you can see, we are getting like 80%. So we are getting way more better result as compared to name bias. And you can here see that the f1 score is also good, but in this case you can see this 4 is pretty much constant. So I am thinking that somehow the entire algorithm has remembered this pattern, or the way we have divided the data into train and test, it's affecting this one. So let's check that one, so whether this data has a real result, the f1 score, the recall and precision, or this is for this distribution of the data. So for that we have to do the cross validation. And for cross validation we are going to use the uh, k-fold stratify. So k-fold, I can select the model selector dot stratify k-fold, and then how many split I want. I basically want a 3 split, and then I want to shuffle no, then a random state I have to give none. And then what I will do, I will just go and split the entire data. For train index, test index in kf dot split, it's x and y. Now what I can do, I have to again just find the x train value and then x test value. So I can find that by train index. So it will give me a data of x train and y train. Let's see it's working or not first. It's working. It's not giving us any error. So let's use the same one, xgboost. I just copy and pasted the same thing here, and here what I will do, I will print matrix. Now run it. Now we got the result. You can see in first iteration we have f1 of 2471, so it's changing. So in the second iteration you can see that it's 83. If I go and see the full detail, you can observe here it's different from what we got here and what we got here. So definitely whatever the result we are getting in the first xgboost call, it's not correct based on the way the data is splitting. So here we have data split, it's changing the result. So in the Second video, in the third video, what we are going to do, we are going to see what is the percentage of frequency in each category, and then we do upsampling.